Hi, my name is Igor, yeah, and I'm here to talk about private rollups and app chains in general. So first, a little bit about myself. So have a technical background, engineering background. I've been in the non-blockchain industry for quite a while. Was building fintech browsers, security, and stuff like this. Then in 2017, joined Status, which is a messenger slash a wallet, mobile wallet. Then for a while, I've been an Ethereum core dev. Likewise, Tomasz from Nethermind, like working on Aragon team, one more node. And I've been doing a little bit of research. If you've been on the Tomasz presentation, he mentioned witnesses. So I was the one who measured them and brought this news. And then right now I'm a CTO and co-founder at GatewayFM, and we are as a company basically we're one of the core devs of the Gnosis chain. We're a little bit helping with like again node architecture on the Polygon zk-VM side, and in general we provide quite a bit of infrastructure that we try to diversify from both the client perspective, client diversity perspective, and also on the data center diversity. So we work with independent data centers around the globe to make sure that like no cloud providers can capture too many of the RPCs and validator nodes. And one of the, you see that we are used by quite a few clients already. And one of the important things that we also like a Polygon Supernets implementation platform, and Polygon Supernets is essentially an app chain platform, and this is what's to some extent inspired this presentation. So at first, I wanted to talk a little bit about just in general what the app chains are, then how can we use private rollups, ZK rollups as app chains, and a little bit of a roadmap should we at Gateway, how we see the future of this. So yeah, basically we start with the basic, what is an app chain? And it's basically, if you can imagine that you have some kind of application or maybe a couple of applications that use this blockchain and you don't maybe even see it. It can be publicly available or not. And it's you can think about it as a basically a mechanism that's very useful when blockchain meets real world, right? Because when you are within the blockchain space, when you are doing DeFi or purely in digital connections and stuff like this, you are fine with blockchain limitations. But then when you work, let's say, try to connect it to fintech or traditional finance, there might be some compliance, security, privacy, or maybe some performance limitations that you just cannot, like maybe the current solutions that's kind of designed to be one size fits all, like a public rollups or public layer ones or something like this, they might not fit. Maybe you want some UX and interesting gaming mechanics or tokenomics within your blockchain that is not available on the on any of the rollups, or maybe too expensive to do on some kind of a smart contract level. So, and you can think about this as also a scalability version of the blockchain. Like way back when we had this Serenity project that was renamed to ETH 2.0, right? When we had the idea that we will scale Ethereum in a way that we have multiple shards, all the shards will be different, some will be executing smart contracts with EVM, some will have some WASM smart contracts with a beacon chain to kind of manage them all. That's one way of like scaling the base layer. But then it was kind of rebuilt in terms of, oh, let's instead of trying to scale the base layer, we will do layers on top of that, like layers 2 rollups, maybe layers 3 later on. And then we see there that this purple applications, they are land on these layers neatly. And with app chain thesis, basically is that you have one-ish like application to one-ish chain. And in this case, I show this is like more of a Ethereum specific when we use private rollups. They all are merged by layer 1 Ethereum here. But there might be like, let's say Gnosis also have this notion of Ethereum verse when you have multiple chains that all run on the beacon consensus, so then you can kind of breach things and treat them as app chains within the same ecosystem. That's another kind of way that's not here. Okay, then the next slide, basically, if you look at modern app chains, again, you have the Cosmos ecosystem or Polkadot or Avalanche that were built forever ago with app chains in mind. We have some ideas of how to do this on Ethereum as well. I'll focus mostly on Ethereum, and I think having the base layer to be like Ethereum or something that's decentralized and neutral is super important here, and I'll talk a little bit in depth later about it. And then if we switch to the rollups themselves, so we want app chains and we want to use rollups as app chains. So what is a rollup? Essentially, it's two things, right? To be called a rollup, basically you need to have some kind of a blockchain that runs, you can call it on top of, let's say, Ethereum, and it has two connections to Ethereum. One is data availability connection. It basically means that in case rollup goes offline, you can still recover the whole state of this rollup using only layer one, only Ethereum in this case. And the second is some kind of a proof on chain there. And then, of course, this setup is a bit expensive to run, often, especially the data availability that usually has scalable cost. The more transactions you have on layer 2, the more expensive it is to provide data availability to it. So there is also a notion of validiums when you just have on-chain proofs, but you don't have data availability on layer 1. Sometimes you might use off-chain availability committee for that, but still it's like a validium. So it's a cheaper version, but then you have a trust assumption that either this off-chain availability committee or the layer 2 rollup operator does not go dark. And the same way you can do basically layer 3 as well, when you can have a layer 2 as a rollup or as a validium, and then have like layer 3 as a rollup on the top of a rollup, which is also one more thing how you do basically the scalability solution. And then we have two types of rollups, right? We have optimistic rollups and ZK rollups. And one critical difference between those two is that in optimistic rollup, the proof that you have to provide on chain is the proof that something went wrong, right? So by default, everything is okay. We're not checking anything, and we're trusting the system, right? But then if, let's say, multiple people are running optimistic rollup nodes, that might be like, oh, this was an invalid transaction that was made. And then you need to kind of prove the system to challenge these things on chain. And this approach supposed to be done by the optimistic rollups. And then we have kind of a ZK rollups where the proof is, it's actually the proof of correctness. The rollup has to publish the correctness proof every now and then on layer 1 to see that all transactions, all state transitions, all EVM execution, everything was done correctly. And I roughly divided it in like 3 generations. So first we had a very simplistic ZK rollups like StarkX or ZK Sync Lite, right? They were operational specific. You maybe could transfer money through it, but you cannot do any generic code execution. Then we have, again, I roughly call it generation 2, StarkNet and ZK Sync era, because it's kind of, they have EVM compatibility to some extent. StarkNet has a transpiler that, again, Nethermind team is working on, for instance, which can take your Solidity code, transpile to Cairo, and then it compiles to the bytecode of StarkNet rollup, right? Then on ZK Sync era, it's a little bit shorter. The process is shorter. It takes Solidity code, and using like LLVM or something, it's compiled towards some kind of a bytecode that's then ZK Sync is using. And then we have ZKVM from Polygon, which is basically a bytecode compatible ZK machine when your Solidity code is compiled to the same bytecode as on Ethereum, and then it's executed in the virtual machine that looks like and feels like Ethereum virtual machine with like a couple of caveats, but they're very minor. Okay, then basically if you send a transaction to a ZK rollup, or ZKVM, let's say, then at first it's just getting sent and then sequenced, means sequencer includes it into layer 2, and then to basically save money on the gas fees, they're getting batched to put them together, because if you put every transaction onto for data availability on layer 1, basically you will have the fees of layer 1-ish. Maybe a little bit less of them, but if you batch them, you might save on the fees. So before it's sent to a layer 1 for availability, you kind of need to trust at this point that the rollup will not like go out of service or will not do anything because it's not yet protected by layer 1. But then as soon as it's sent to the data availability, you can at least again recover the state if you want. And then after that, usually quite a beefy server generates a proof for this batch of transactions and sends this to L1 smart contract. And this L1 smart contract actually checks the validity of this proof. And the proof is basically, it validates all the state transitions, all the application of these transactions. And as soon as proof is sent to L1 and validated there, you can basically, at this point, you can think that it actually has security guarantees of the base layer of Ethereum. Before that, you still have some trust assumptions of a rollup. Here I want to switch 2 slides. I don't think we will, yeah. So the data availability is one more thing. It's like there are 2 approaches to that. Basically, one is when you send inputs of transactions like Polygon ZK-VM. Basically, it sends transactions to be executed in batches in layer 1. And then the other approach is, if I understand zk-sync and Starknet is doing this, is that they store on chain already the state diff, what the differences, what changed in the blockchain after the transaction was applied. Like each has its own kind of a pros and cons approach. So yeah, that's another 2 things. So basically, if we combine all of this together, we're looking into using this ZK-VM or some kind of rollup technology that has the security and data availability of layer 1 and use it as an app chain. And there's like a couple of the current already tools that are kind of based on the rollup. You see like there are super chains, there is Saga, there is like tools like Caldera that takes the optimism stack and stuff like this and set up a rollup for this. So, and now the point of contention with the app chains was always kind of a centralization. And to kind of, I'm giving it, if we're using the right technology, then like I think we can give it a little bit of a, I would say it's a little bit less requirements of decentralization on the app chains. And the reason for that is that I say that decentralization is not the kind of a, it's a good thing, but it's not a goal in even of itself, but the properties of decentralization is what we actually care about. And there are 2 properties that I want to show here. And the one property is liveness. Basically, if your system is properly decentralized, that means that there is no single entity that can shut it down, right? So in case, like, let's say if Ethereum is really well decentralized, no matter like if, let's say even Lido goes completely dark, Ethereum will still be working, right? Or let's say if Infura goes completely dark, Ethereum will still be working. So there is no single entity that controls it. And the second is that it's basically user agency, which is also very important. And user agency means that regardless of what a single or like couple of entities want, really, users still can participate in the network, and users still can, if needs to be, like exit this network. So these properties are like what's important and they are actually achieved through decentralization in terms of base layer. But since we are building app chains as rollups on top of this base layer, then we can kind of have something of this, something similar for that without having to completely decentralize things. So first, of course, there is still a property of liveness that's very, very useful. But since rollups usually, or should publish the data availability onto the base layer like Ethereum, you can, like, even if rollup goes dark, you can still just launch it yourself and have all the same state as it would have been in the rollup that was running by the original team. Of course, there is like a caveat that you need to be able to run these things. So it means that it should be open source at least, and it should be able to run. There shouldn't be any hidden components to this. And also, of course, the smart contracts for this, they should be well audited, and it should be like proven that they actually publish what they claim they publish, right? And the second is that with this computational proofs and usually the notion of either forced exits or forced transactions or something like this, it means that you as a user, again, for an extra fee, but you can force, regardless of what the sequencer or people who run this centralized sequencer think about, like you participating in the network or you exiting the network, you can still force them into like executing a certain amount of transactions. So in ZKVM, like in Polygon, yes, there is a notion of like a forced transaction. So it could be like any transaction that sequencer has to include, regardless of if it wants to censor it, it just cannot censor it. Or if the sequencer itself will not include it, then you can run a sequencer that includes it, basically. And then there are also some kind of a caveats to this. And one caveat is, of course, that the state is not changed yet until at least you have data availability transaction sent to the Ethereum, and until the proof is, ideally, the proof has come to Ethereum as well, it was verified, right? You cannot trust fully the state in this case. And the second is, of course, that's what I talked a little bit earlier, is that it actually brings quite a lot of requirements on the underlying layer one. I mean, if your underlying layer one is run by the same entity as layer two, only one entity, then you don't have anywhere to exit. Like you basically, you will collude one way or another. So about non-finality, and that's a little bit of a thing that it wasn't really formally described before, I think, proof of stake consensus, but you all seen like in your wallets or something that, oh, this transaction has this many confirmations on top of this, maybe some operations are executed when it has 12, some executed when it's 24. But like when it was proof of work or in Bitcoin days or legacy proof of work Ethereum, basically you didn't have this notion, okay, this transaction is final and will not be reverted. It just, with each next block on top of this, is harder and harder to revert it, but theoretically not impossible, right? At certain length, it becomes purely a theoretical exercise, of course. But then with Beacon Chain, there is a notion of finality. For instance, there is a thing called Casper friendly finality gadget in Ethereum consensus. When, for instance, your blocks are grouped into epochs, and when there are at least 2/3 of validators online, it kind of marks this epoch as final, and that means that it's guaranteed by the protocol that the transactions in this epoch will not go anywhere. And I would argue that ZK rollup also have this notion of finality, and this notion is when the proof is proven on the layer one, right? After that, you kind of have these guarantees that, well, I mean, if you're going really, really deep, then when the proof is checked by layer one and it's final, like because layer one also can rework in theory, which is very unlikely. But then you also have this, you can kind of transaction, okay, this transaction in theory, if somebody who runs sequencer really wants, can be reworked away. But then as soon as the proof reached layer one, there is nothing to do for the ones who run the sequencer. So that's why I also want to have this notion of finality in the rollups, in ZK rollups, and it's important. And then again, base layer neutrality. Basically, you exit into the base layer, you exit into Ethereum or maybe to Gnosis or something like this. And base layer for this, it actually needs to give you this property of agency and liveness. And since it's a base layer right now, we don't have any better tools to give it to user than good decentralization. So, and I would say that this kind of a property of, again, neutrality, if you want to call it, when single entity cannot like censor you or something like this, it can a little bit bubble up, again, with a certain caveat, with a less strict guarantees, upwards if you're using, let's say, zkVM rollup on top of zkVM rollup on top of Ethereum, and Ethereum is well decentralized, then with certain caveats, you can think that layer 3 is also can bring some of the security and decentralization, not decentralization, but liveness and agency to the user. So to put it all together, if we take zk rollups and start building up chains on this and base it out of credibly neutral and decentralized networks like Ethereum or Gnosis chain, for instance, you can get a lot of the properties of the app chains that you want, including the custom tokenomics, performance characteristic, just prices and stuff like this, or compliance, for instance, benefits for certain regulated industries, while still giving these properties of agency and liveness through data availability and computational zero knowledge proofs, for instance. So that's kind of the thesis that I did. And then to bring it into more action, then I wanted to say that there's of course, caveats are everywhere. The one thing that I forgot about, there is still, like if you're doing DeFi, for instance, especially on the app chain approach, you will end up with liquidity pools being quite fragmented. So right now, the biggest liquidity pools are on Ethereum. Some of them, of course, are on shared rollups like Arbitrum, Optimism, and stuff like this. But then there's one thing that's if you're doing DeFi on app chains, that's one of the trouble. And there, like things like shared sequencers approach could potentially help, or some bridges like LX12Y from Polygon zkVM, or this Hashi that's system that Gnosis is working on. Then, of course, purely constructing these zero knowledge proofs is expensive, means hardware expensive. You need to rent a pretty beefy server at this moment. Of course, the teams are working really hard to take this cost down, but still, like, you need to run quite a bit of a server. And if for each app chain you have to provide this server, it bumps the cost up quite a bit. So for this, I would say that first we can work on the efficiency of the proofs themselves, algorithmically, or maybe using more specialized hardware or something like this. Or we can use also shared prover across multiple app chains, so we don't have to provision it many times. And then there are base layer fees, of course, because both data availability and proofs are sent to the layer 1. You will have to pay gas fees on the layer 1. So, and these fees are, again, for data availability, they are kind of they dependent on the size of the amount of transactions you want to send there or something like this. For the proofs, they are basically, they're more or less constant, but still, let's say state diff approach wins here because it's cheaper, because you can bundle a lot of transactions. Let's say if we had 5,000 transactions between only like me and Tomasz, for instance, there will be a very short state diff for 1,000 transactions there, right? Which might work in the cases, again, when you have super popular single application, when everything is changing in one smart contract. Or we also can work like basically more efficient in terms of maybe some recursive proofs to make the proof themselves smaller and smaller, to be able to include multiple proofs in a single aggregated proofs and stuff like this. So now to the practicalities. So one of the things that is happening is that, like on the Polygon supernets, basically the future supernets, there is more and more moving towards that there will be private rollups on top of Ethereum, for instance. So that's kind of the typical supernet high-level architecture. And now it's, instead of having their own validators, their own kind of a stake and stuff like this, it's more using layer 1 RPC to be able to synchronize it. And we at Gateway want to also take it like a little bit a step further. Again, it's a little bit a long-term vision is when we want to allow users to create their own, not only like a rollup, but the whole like environment with just a couple of clicks, with like both the block explorers, I don't know, identity providers, wallets, like multi-sigs and stuff like this. And basically to provision it with a couple of clicks and maybe like a couple of minutes after this waiting time. So yeah, so that's basically it. That's what I wanted to say. So feel free to reach out to me either here if you have any questions or want to just discuss this thing. Here is like our official Twitter, my Twitter. On the public GatewayFM, you can find a lot of, again, public RPC. If you want to like use it in your project, like they don't even require registration. And here's my Telegram handle. So yeah, I think that's it for now.